Hi, welcome to the Stone Sizzle channel, and today we're going to be talking about the intermediate value theorem. What I'd like you to do for a moment is imagine you're in an airplane about ready to take off on a journey somewhere fun, hopefully. If you're in that airplane and as it takes off, we'll say it takes approximately 20 minutes to get to an altitude of 30,000 feet. Since we know that the path of that flight that the plane takes is continuous, we know that at no point can it skip a particular altitude. It must hit every altitude from 0 to 30,000 feet. So if we wanted to say, make sure or verify that it hit the altitude of 9,120 feet, we are positive that it has met that altitude at some point on the interval 0 to 20 because of the continuity of the flight path of the airplane. We're going to be talking about this in a little bit more formal way, and we're going to start by looking at the intermediate value theorem. The intermediate value theorem states that if f of x is continuous, and you see it's highlighted because it's important, on a closed interval from a to b, where f of a is not equal to f of b, then for every m in between there exists at least one c value in that interval a to b such that f of c is equal to m. So at this c value, if I evaluate this function, it's going to be the value of m. F of c equals m. That is the intermediate value theorem. This is known as an existence theorem because it only helps us show that c exists, but it does not help us find the value of c. Let's look at a very common example using the intermediate value theorem. This example is asking us to show that the equation has a root on the given interval. Well, you need to know what a root is first, and I'm hoping from your previous learning in other classes you recognize that a root is sometimes called a solution, sometimes called the zero, sometimes called an x-intercept, because that's where it crosses on the x-axis. So let's look at this polynomial function. We know that polynomial functions are continuous, especially continuous on the interval 1 to 2. So now what we're going to do is to prove or to show that it has a root on that interval. We're going to do that by first evaluating this equation at each endpoint. We are going to find that we evaluate this function, this equation at 1, we will get a value of -3. When we substitute in 2 into this equation, we're going to get a value of 5. Now you may think for a second and be able to intuitively figure out that if at 1 we're at -3 and at 2 the y value is 5 and it's a continuous function, it's going to have to at some point on the interval 1 to 2 cross that x-axis, and that would be true. That if here is my 1 and here's my 2 and I have -3 down here and 5 up here, and we have a continuous function, it's going to have to cross that x-axis. It's going to have to equal 0 at some point. That, in a nutshell, is the intermediate value theorem. Let's take a look at a couple other examples. This one is asking us to prove that f of x equals x squared takes on the value of 0.5 on that interval. So how do we do that? Well, we're going to evaluate the function at each endpoint of the interval and see that when we substitute 0 into that function, we're going to get 0. And when we substitute 1 into that function, we're going to get 1. Well, I think it's obvious that we can see that f of 0 is less than the value we're looking for, 0.5, and 0.5 is less than f of 1. So again, it just shows us that that value exists on the interval 0 to 1. To look at it a little bit more formally, here is something out of your textbook that you can look at how they wrote the solution. if you notice, they talk about the fact that x squared is continuous on that interval. They evaluate it at the endpoints. They write the similar inequality that I did, and they say the intermediate value theorem guarantees that there is a c value in that interval, such that when you evaluate it at c, it's equal to 0.5. Again, it doesn't help us find what c is. It just shows that it exists. Let's take a look at one more example. Now, when you look at this example, I would hope that you would pause this video at this moment and kind of take a moment to see if you can come to your own conclusions using the intermediate value theorem. So I'll take a minute now. I'll let you pause it. I hope you had an opportunity to take a look at this and recognize that x cubed plus x is a continuous function, and we want to see that it takes on a value of 9 in the interval. So again, I hope that you evaluated the function at each of its endpoints, found that f of 1 is equal to 2, and when you substitute 2 into that function, you're going to get, what is that, 10. So we can see that f of 1 is less than 9, which is less than f of 2. So we can tell that because it's a continuous function, and this inequality is true, that it's going to take on some value of 9 in that interval. Here again is the more formal approach that I want you to kind of get in the habit of looking at and reading, because there are some important pieces in there. Again, they evaluate the... there's a little mistake right there, isn't there? This f of 2, that's interesting. 2 2s are 4, 2 4s are 8, plus 2 is 10. This should be a 10 right there. That's very interesting. Little mistake from the book, it looks like. Since f is a polynomial, it is continuous everywhere, in particular on 1 to 2. Therefore, by the intermediate value theorem, there is a c that exists such that f of c is equal to 9. Now I want to look at just why it's so important that the function is continuous. So if you're looking at here, here's another example of that altitude using an airplane. It says altitude of an airplane. You can see it's a continuous path. I can drag this along just to show you that it has to hit every one of those y values, or every one of those altitudes, as we go through the progression of time on that interval of time. But if you look at this function, this step function, this greatest integer function, it's not continuous, and if you'll notice, it skips and jumps values. So it's not hitting every value between 0 and 1 or 1 to 2. So it just shows you the importance of the continuity for the intermediate value theorem to work, and that's why they stated it in each one of the solutions. Well, I hope you enjoyed this little video in intermediate value theorem. Be prepared to apply this theorem when you come to class, and enjoy the rest of your day. Johnstone, out.